Good morning, students. We are trying to discuss this MCQ worksheet. Okay. So, this first question. So please don't look at the video and read the question. I'm just pointing the video to the question just for your reference. But use the printed sheet I have given you, or else it is available in class notebook. A cup contains hot liquid. Some of the liquid evaporates. What happens to the mass and what happens to the weight of the cup? So during evaporation, particles leave the water surface, which means that the mass will decrease, and weight is mass times gravitational acceleration. So if mass decreases, weight will also decrease. So the answer for question number 1 is decreases. Answer A. Question number 2. Which statement about evaporation is correct? So the main thing here is correct. Evaporation causes the temperature of the liquid to decrease. Now, as we learned, so in evaporation, the high energy particles leave the liquid, which means the average going to drop. So when the average kinetic energy drops, then temperature will drop. Now you need to understand temperature of a liquid or a gas or any temperature of a molecule depends on the average kinetic energy of the molecules, even for solid. So, and it depends only on the average kinetic energy. So when the temperature changes, average kinetic energy changes. When the average kinetic energy changes, temperature changes. Evaporation, answer B, evaporation does not occur from a cold liquid near its freezing point. No, evaporation occurs at all temperatures. That is one of the main difference between boiling and evaporation. Evaporation does not occur from a dense liquid such as mercury. It occurs in all liquids. Evaporation occurs from all parts of a liquid. No, it is a surface phenomenon. It is a very superficial thing. The reason is, even if there is high energy particle deep down in the liquid, it would need tremendous energy to come to the surface, breaking all the bonds in between, and by the time it comes to the surface, it would not have sufficient energy to become gas. So the answer is A. So be careful about the keyword correct. They are not asking which is the incorrect one. So second question, answer is A. Did I say B earlier? Sorry, it's A. Okay, so the correct one is A. That causes the temperature of the remaining liquid to decrease. Third question, a gas is stored in a sealed container of constant volume. The temperature of the gas increases. This causes the pressure of the gas to increase. What happens to the gas molecule during this pressure increase? What happens to the gas molecule during this pressure increase? You see the temperature increases. So as I said, temperature will affect the average kinetic energy. So the average kinetic energy of the molecules will increase. So temperature and average kinetic energy are related. The average separation of the molecules decreases. Now the volume is kept constant. The molecules in a gas are randomly moving in all directions. So the distances between the separations will not change, because the total volume, the total distance the molecule should move, the volume of the container, that remains the same. The average separation of the molecules increases. Again, as I said, it will not change. The volume of each molecule increases. That never happens. The volume occupied by the gas molecules might change, but not the volume of the molecule itself, which means now there are situations where there will be situations where the volume might be increased. For example, when you are inflating a balloon, so the volume might increase, you might have a greater volume, but if you consider the molecule itself, the molecule's volume will remain the same. It will not, like when the volume becomes bigger, the molecule's volume will not become bigger. So the volume of the molecule would remain the same. So the answer for question number 3 is A. Question number 4. A liquid is evaporating. The liquid is not boiling. Which statement about the liquid is correct? Any molecule can escape and from any part of the liquid. Wrong, as I said, only the surface. Any molecule can escape, but only from the liquid surface. Yes, but there is only one issue. The issue is that it is saying any molecule can escape, which means that even the molecules on the surface which have low kinetic energy can escape. No, that's not the case. There are two things: only the surface molecules, and they should have enough energy to escape, right? So if you look at answer C, only molecules with enough energy can escape, and only from the liquid surface. So that's true. So from the surface with enough kinetic energy. Only molecules with enough energy can escape, but from any part of the liquid, again wrong. Only the surface. So the answer for fourth question is C. Fifth one, the diagram shows a quantity of a gas enclosed in a cylinder by a piston. The piston is moved to the left or to the right. The temperature of the gas is kept constant. So the main thing is temperature being kept constant. Which row describes the effects of moving the piston slowly in the direction shown in the table? So when the temperature of a gas is kept constant and the mass of the gas is kept constant, then we know there is a law which says P1 V1 equals P2 V2. Initial volume times initial pressure equal final volume times final pressure. So according to that, which will describe the effect of the piston slowly in the direction shown in the table? Movement of the piston. So when the movement of the piston to the left, speed of gas molecules. Now you can cut off the answers easily using the second column because the temperature is kept constant. That means there should be no change in the speed, right? So that takes away the answers A and C, where they say the speed changes. As long as temperature kept constant, speed should remain constant. So that takes away answers A and C. In B and C, to the left, volume is decreased, so pressure should increase. So B is correct. In D, volume is increased because the piston is moved to the right, so the pressure should decrease, but this says as increases, so that's wrong. So the answer for fifth question is B. Sixth one. What causes the random zigzag movement or Brownian motion of smoke particles suspended in air? Air molecules collide with smoke particles. Yeah, the collision between the air molecules and the smoke particles is what that is causing the zigzag movement or the Brownian motion. Convection currents as the hot smoke rises. Now you will study about different thermal conducting methods: conduction, convection, radiation. But once you know about convection, you will understand. But in that case, the air molecule, the smoke molecules will follow a constant trajectory. Like the molecules will, even if they move in zigzag, they would move upward. But there is no such necessity here. Here it could move upward in one time and then move downward like that. It's zigzag. So if it was due to convection current, it would be only upward in direction, like on average. Then smoke particles colliding with each other, no, because we use only small amount of smoke particles, so they are not enough to collide among themselves to have that zigzag pattern. Smoke particles reacting, there is no chemical reaction happening. So the answer for 6th question is A. 7th, a sealed bottle of constant volume contains air. The air in the bottle is heated by the sun. So this is a situation of constant volume and temperature is increased. What is the effect on the average speed of the air molecules in the bottle and the average distance between them? So if you look here, it is heated, so the temperature should increase, which takes away the answers A and B. Then the volume is kept constant, so the average distance between the molecules should stay the same, so the answer is D. 7th, the answer is D. Air in a sealed syringe is slowly compressed by moving the piston. The temperature of the air stays the same. Temperature stays the same. Volume is being decreased. Which statement about the air is correct? The pressure of the air decreases. No, volume is decreased, so the pressure should increase. The pressure of the air decreases because the area of the syringe walls is now smaller. No, the area of the syringe walls remains the same. The pressure of the air increases, right? The pressure increases because its molecules now hit the syringe walls more frequently. So as we know that pressure is due to the rate of change of momentum. Now since the distance that the air molecules have to travel is smaller, they will hit the walls more often, so there is more number of change in momenta happening for a given time, so there is more force, hence more pressure. So answer for the 8th question is C. And the D part, let's check that. The pressure of the air increases because its molecules now travel more quickly. That means speed, no. The temperature constant, speed is constant.